Hello guys, welcome to the second lecture in the series of lectures of matrices. In this lecture we shall talk about, we shall actually solve a few questions on the concept we learned in the previous lecture about trees of matrices. So this question has appeared in ISA aptitude test, and the question says that if AN and BN are two square matrices of order 3 which are defined in as AN equals to Aij and BN equals to Bij, where Aij equals to 2i plus j upon 3 to the power 2n plus, and Bij is defined as 3i minus j upon 2 to the power 2n for all I and j where I is always greater than 1 and j is always less than equals to 3. And the question says if L is defined as this, if L is defined as such and M is defined as such, we have to find L plus M by 3. So first let's talk about AN, and then we'll generalize it for AN, and then we'll also talk about. So let's solve it. So we can see that AN is 2i plus j to the power upon 3 to the power 2n. Okay, so A1 would be 2i plus j upon 3 to the power 2. A2 would be 2i plus j upon 3 to the power 4. Just we are putting any values of n in this respective terms, and we can see that 2i plus j is common in all the terms, so we can take it out and we can simply write. So the question says trace of 3a1 3 square a2, so 3a1 would be this, I'm calling this particular term as p, so p upon 3 square a2 would be p upon 3 square. Similarly 3 cube a3 would be p upon 3 cube. Okay, because the term would be 2i plus j upon 3 to the power 6, and we divide it by 3 and we multiply it by 3 cube, so 3 cube cancels 3 to the power 6 by 3 cube. So we can find L equals to so we can find this trace of 3a1 plus 3 square a2 all the way up to 3 to the power n an. So but we have to find, so 3a1 is p upon 3, and this is p upon 3 square, this is all the way p upon 3 to the power n, but since it is sum of infinite gp, n tends to infinity, so this goes all the way up to infinite. Okay, we can take p out, this becomes a gp, so 1 by 3 square all the way up to infinity. So we can find some of these infinite gp with the help of our formula which we learned, that is a upon 1 minus r, and that is 1 minus 1 by 3, that is I think 2 by 3. So this is 1 by 3 into 3 by 2, so this cancels and this becomes 1 by 2, so actually it becomes p by 2. But what is p? So p is this 2i plus j, so and this 2i plus j, and because we are finding trace, so we have to find all the diagonal elements. So instead of I and j, we'll put first I equals to 1 and j equals to 1, then we will put I equals to 2 and j equals to 2, and then we will put I equals to 3 and j equals to 3. So this becomes p equals to first we will this is sum of all diagonal elements, so first we will put I j equals to 1 1, so it becomes 3, plus we will put 2 2, so it becomes 6, and then we will put 3 3, so it becomes 6 3 9. So p equals to 18, so L equals to 18 upon 2, that is 9. Okay, so L comes out to be 9. Similarly we will find M, but we have to find 2b1. So let's talk about b1. So b1 is 3i minus j upon 2 to the power 2, but we can also find this b1 as, because we have to put ij, because it is all diagonal elements, because we are talking about trace, and in trace we talk about all diagonal elements. So b1 is, we'll put 1 1 and 2 2 and 3 3, so this whole thing, so we can write this as also as, when we'll put 1 1, this will become 2. When we put 2 2, this will become 4, and we will put 3 3, this will become some what, so 9, and there is 6. Okay, when we put 2, this becomes 6 minus 2 4, and when we put 1, so this becomes 3 minus 1 2, and we will put 3, so 9 minus 6 3. ठीक है, so this becomes this, so 6 4 10 to 12. Yes, so b1 is 12 upon 2 to the power 4, 2 2 square. b2 is 12 upon 2 to the power 4 all the way up to bn is 12 upon 2 to the power 2n. Okay, so and we can simply, I mean, and we can simply calculate it with the help of our formula we learned. So let's do it. So trace of 2b1 plus 2 square b2 all the way up to 2n bn equals to 12 upon 1 by 2 plus 1 by 2 square plus, so we can actually write it 6. So 2b1 is 1 by 2, this is 1 by 2 square plus 1 by 2 cube and all the way up to infinity, because sum of n tends to because n tends to infinity, so we can calculate it. So this is 12 into 1 by 2 into 2 upon, I am calculating some of these all infinite GPs, so a upon 1 minus r, so a upon 1 minus r, so this is 1, so this becomes 12, so m equals to 12, therefore L plus m by 3 equals to 9 plus 12 by 3, that is equals to 7. So that's the solution set of that's the solution of this particular problem, and this is the first method. We will solve it by another method that is more elegant and more trivial, because instead of writing this, so what we did is we write the first and two terms, and then we intuitively thought of the pattern that it appears. So that's one method. Let's solve it by another and more simpler method. Now let's solve this question by another method, and that is more simpler method. In previous method we simply wrote terms and we find out the pattern that following, and we expanded that pattern to solve the question. Here we are simply writing the problem as it is saying. Okay, so let's solve it. So an is given as, an is defined as aij, and aij is something like this: 2i plus j upon 3 to the power 2n, and the question says that it's a 3 cross 3 matrix, so we can also write this as something like this. So this is the first, and this is because we are writing diagonal elements, so we can write this is 3 upon 3 to the power 2n. This would be, we'll put 2 comma 2, so this will be 4 plus 6, this is 6 upon 3 to the power 2n, and this will be 9 upon 3 to the power 2n. Okay, that's the, so this is an. So what will be 3 to the power an? 3 to the power an will be simply this. So if this is an, 3 to the power an would be, so 3 to the power n would be, we'll multiply 3 to the power n here, that's 3 to the power an. Okay, so that's the that is 3 to the power n. Now what is trace of 3 to the power n? That is 3 to the power n, and we will add all these diagonal elements, so it is 18 upon 3 to the power 2n. Okay, so that is 18 upon 3 to the power n. So this is trace of 3 to the power n. Okay, 3 to the power, let me write it more clear, that is 18 upon 3 to the power n. Okay, but you have to but L is defined, but we can write L as limit n tends to infinity summation of trace of 3 to the power n a r. Okay, so and we can expand r equals to 1 to n. Let me check it once. And yes, it is right. So and so it will be 1 upon so it will be 18 because this, and we'll put n equals to 1 to, and so and we'll just write r as such. So this would be 1 by 3 plus 1 by 3 square all the way up to 1 by 3 to the power n, where n tends to infinity. So this is sum of all infinite terms, so we don't need to even write that. We can simply put the infinity symbol, and this is 18. Okay, sum of all these would be 1 by 2. So this is 18 by 2, that is 9. So L comes out to be 9. Okay, similarly we can find for B. So 2 to the power n Bn is 2 to the power n, and this would be 2 to the power 2n. This would be 4 to the power this would be 4 to the power 2n. This would be 6 to the power 2 to the power 2n. So 2 to the power n actually. So it's 2 to the power 2n actually. So 2 to the power 2n this is. Okay, so trace of 2 to the power n Bn would be 2 to the power n, and this is 6 4 12. So 12 upon 2 to the power n. So 12 upon 2 to the power 2n, that is 12 upon 2 to the power n. And again we can do simple that. So m equals to 12 1 upon 2 plus 1 upon 2 square all the way up to infinity, because sum of all infinite terms. This is 12 upon, and this would be 1 by 2. So 12 by 2, that would be 6. Okay, no, so this would be sum of all the diagonal elements would be let me just calculate it. So 12 into 1 by 2 into 2 by 1. So this would be 1 actually. So 12 is m comes out to be 12. Therefore L plus m by 3 equals to 12 plus 9 by 3, that is equals to 7. So that's the very famous and very good question. That's a very good question. So we'll solve another few questions, and then we'll wrap up about trace of matrices. Okay, let's solve another question. So this is the second question in the series. So this question has also appeared in Eiger aptitude test and has appeared in JEE Advanced when it was pure descriptive. So solve it. Let's solve it. But before solving it, we have to analyze questions more precisely. And the question, after being analyzed, we would find that these two terms, that B and C, are very kind of very, because if you see this is 3 3 and all that. So we'll solve it, and we can see that BC upon 2 is actually kind of making a GP out of here. So this is ABC by 2, this is BC square, BC by 2 whole square, and all the way up to infinity. So let's solve it. So let's first find BC. So if we multiply BC, that is 3 4 2 3, and multiplied by C, that is 3 minus 4 and minus 2 and 3, we will find that is 3 3 6, and 3 3 is 9, and 4 minus 2. So this is 1, and this is minus 12, and this is plus 12 0. This is 6 and minus 6 0. This is minus 8, and this is 9. So this is 1. So this gives identity matrix. Okay, this gives identity matrix. This is I. Okay, so we can simply this is actually BC equals to this equals to I. Okay, now it is very easy. So for us to, so the question says trace of ABC by 2 is, we can, because BC is I, so we can write trace of ABC by 2 is trace of A by 2. So this whole thing becomes a trace of A by 2. This becomes trace of A by 4 all the way up to infinity. Now we can see that this is we know in a trace we can take a constant term out. So we can take 1 by 2 trace of A, this 1 by 4 trace of A. So this forms GP. So we can take trace of A common, and we can see that 1 plus 1 by 2 plus 1 by 4 all the way up to infinity. Okay, so what would be this? This would be 1 sum of infinite terms, so 1 upon 1 minus r, that is 2. So this becomes 2 times trace of a. And what is trace of a? We can see the trace of a is 3. Okay, so 2 times trace of a equals to 6. So I think that's our option A. Okay, so that's second question. We'll talk some we'll discuss some more questions and then we'll wrap up. Okay, so this is the third question in the same series, and A1 is 1, matrix of order 1, A2 is matrix of order 2, and A3 is matrix of order 3, A4 is matrix of order 4, and it is formed by consecutive natural numbers. So A1 is 1, A2 is 2, 3, 4, 5, A3 is 6, 7, 8, 9, 10, 11, 12, 13, 14, and all the way A4 is 15. We have to find trace of A10. Okay, we can analyze something. In A2, this trace was 7, and difference between diagonal elements is 3. So if we write it as GP, so this is AP, as this is the common difference is 3. Here this is 10 minus 6, 4, and this is 14 minus 10, 4. So common difference is 4 in trace. In A4, common difference is 5, 20 minus 15, and 25 minus 20. So this is kind of one clue we can get out of this. So that we know that D in trace, D would be, let's solve it. So D would be equals to n plus f1. It was A2, so it was D was 3. For A3, D was 4. For A4, D was 5. Okay, that's so. While solving it, let's do some calculations. What are the first terms of all? So A1 का first term 1 है, A2 का first term 2 है, A3 का first term 6 है, A4 का first term 15 है, all the way up to like this. Okay, what we can analyze, this is 1. What is this? This is 1 square plus 1. This what this sorry this is 1 plus 1 square. What is this? This is 1 plus 1 square plus 2 square. What is this? This is 1 plus 1 square plus 2 square and plus 3 square, all the way to. So what would be the first term of A10, or for any, let's say for AN? So first term of AN would be 1 plus 1 square plus 2 square all the way up to n square, n minus 1 square, because in fourth it was 3 square, in 3 it was 2 square, all the way up to n minus 1 square. Okay, so this would be 1 plus this is sum of squares of n minus 1 natural numbers, so this is n into n minus 1 into 2n minus 1 upon 6. Okay, therefore, and now we got the first term and we got the common difference. We got the first term, this is the first term of any AN, and this is the common difference. Now we can find sum of all diagonal elements. So, and this is common difference of diagonal elements, keep it in mind, this is common difference of all diagonal elements. So this is so in first term, at this we will get second term, at this we will get third term, we'll get at this we will get fourth term, and we can simply add it, and then we will have trace. Okay, so trace of for example, let's say AN would be n by 2 into 2a, and this is first term, so 2a, that is 2 into 1 plus n into n minus 1, this is 2n minus 1 by 6, 2a plus n minus 1 into d, that is n plus of 1. Okay, this is trace. Okay, and we have to find A10. Okay, so we'll put n equals to 10 here, so let's put it. So this is 10 by 2, this is 1 plus n into, let me just calculate it first, n plus -1 because this cancels here. Okay, because here will be 1 minus 1 and this will be 2, so this 2 and this minus 1 will make 1, and this will be n into n minus 1 into this is 2n minus 1 upon 3, because this 2 will multiply here, and here we'll have n square because plus and minus n will be cancelled, and we can put simply n equals to 10 here. So let's put n equals to 10 here. I'm taking this out here, so this is 10 by 2, that equals to 5, and this is 1 plus, we'll put 10, so 10 into 9 into 19 by 3 plus 100. Okay, plus 100, so this would be, I think, 3, so this would be 5 into 101 into 570. This 1 and 100 is 101, and this will be 570. Yes, no, 57 into 25, 570, and this would be, I think, if you multiply, I have done multiplication earlier, so this will be 3375. So that would be the trace. Okay, so that's a beautiful problem, and that's the solution. That's all for trace of matrices. Now we shall learn about matrices of symmetric matrices and skew symmetric matrices. So that's all for trace. Thank you, and please like, share and subscribe. Thank you.